Hello everyone, my name is Brad Tallis from Autodesk. I want to welcome you to another episode of Fusion 360 Live. Today's topic, we're actually going to be taking the laser projector and assembling it all together. We've been spending quite a few weeks learning how to create the different parts, the plastic parts, the gears, all the internal components, and today we're going to start assembling them together. I'm going to start out by apologizing. Unfortunately, the YouTube live stream was put in at the wrong time. It was set to, supposed to be 12 o'clock Mountain Time. It was set to 12 o'clock Pacific Time, so I know some of you are probably going to join and miss this, but luckily the YouTube video will be out there for you to join. That's my fault. I'll take responsibility for that, so I apologize. On the keyboard, I have Jason helping me out, so if you have any questions or comments or anything like that, please feel free to throw them out into the chat. And also, after the video is over with, please feel free to add any comments into the comments field in the video. Okay, so let's dive in. What we're going to be doing today is actually assembling all of these parts. Now, I did put a file in the description of the video that has all of these parts, and we've been going through and creating most of them, but you'll notice there's a couple in here that were pretty simplistic, like a pane of glass and a mask, etc. This little drive shaft. I'm not going to spend time showing how to model those, so I just went ahead and incorporated those in that package. I also included my outline that I usually use. So if you want to download that outline at a later time and kind of go through it step by step to kind of see, to kind of review this video, please feel free to do that. Okay, so what we're going to do is, and in fact I'll jump back to the camera here real quick. This is a little bit different than how I typically design. So what we're doing here is we're designing a single part, we're saving it, we're designing another part, we're saving it. And today we're going to bring those individual parts or components into an assembly. This is similar to how you would do it with like Pro-E or SolidWorks, for example, and that's kind of why I'm showing this methodology. I personally like to design what I call in context. And what do I mean by that? Well, for example, I might design this part, and then I will also, in the exact same session, design this part, and they'll be in the correct location and everything like that. I'm not having to save them out individually and then bring them in. However, today you're going to see some of the cool functionality by doing that part by part, saving it, and then bringing it in individually, because they're all going to be linked together, and you're going to see some magic behind that. So what we're going to do here is I'm going to start out by, I have a new session, and I'm going to go ahead and just save this. So I'm going to call this, I'll just call this the whole assembly. Okay, and you're going to see it's going to go from, I can't even spell it right, I apologize. It went from untitled to whole assembly, okay? And it's going to create a file, and right there, called whole assembly. And then what I'm going to do is I'm going to insert these in. So if I right click on this back housing, I'm going to say insert into current design. And what you'll see is it's going to load this into my current design. Okay, so I must have put this, let me start over here, apologize. I want to make sure I'm in the correct location, so save. Yeah, that's what the problem was. It didn't save it into my project. So let me jump into the correct project here. So I'll go into Tech Thursdays, we'll do this star shower and this live stream. Okay, so now I can call it whole assembly, and I'll spell it right this time. In fact, I'm going to put a 2 after it just in case. So now it's going to save that, and now I should be able to insert into current design. And what this is going to do is bring that file into this whole assembly. Now, here's the important thing. You'll notice it allows me to move. And when we were creating these parts, we pretty much designed them around the origin, okay? And this will make more sense here in a little bit. And when I bring these in, they're all going to come in at that origin. So I'm going to pull this guy back a little bit. And just for fun, I'll move him over just so he's not perfectly lined up. Now, what's interesting about this is you get a free move anytime you insert in a component, okay? You'll notice when I say okay, I don't get that capture position or revert position. But if I were to come in here and now say move, for example, and say, you'll notice it says capture position, or if I say okay, you'll notice those icons appear. So take advantage of that free move. So for example, I'll do the center housing. So I'm going to insert all of these in individually and see, sure enough, how that kind of came in near the origin. So I might bring this back a little bit. Let's bring it up. You'll notice it doesn't say capture position and I don't get those icons. So you get a free move basically whenever you do this. And so all I'm going to do is step through and insert these in. Now I'm not going to do every single part because that would take, probably about 5-10 minutes of our time or whatever. But I'm just going to kind of showing you what happens when we insert these into our current design. So I've got my housings. Here's a perfect example. Notice how that gear came in exactly at that origin. In fact, let me show you what would happen. I'll go ahead and leave that there, and I'll show you why I'm moving these. Okay, so I insert that guy, but now when I bring in, for example, like the stake, let me insert this into the current design. It's gonna come in at 0, 0, and now our gear is kind of like buried inside the part. So this is why I've been moving these around. And again, I'm just kind of positioning them out in space somewhere. It really doesn't matter, okay? Okay, now to save time, I've already brought all of the parts in, kind of the cake in the oven type thing. So I'm gonna go ahead and close this guy out. And I've done everything I just did. I brought these all in. You'll notice they're no longer right on the origin, okay? I'm going to highlight a couple parts. So you'll notice I have a circuit board, and this is using our new PCB abilities inside of Fusion. And I did have somebody ask me, are you going to show how you did this? And I will. Actually, Edwin made this for me. He's been doing a lot of live streams on the PCB ability. So I highly recommend watching those. I think they're on Wednesdays. And so he made this for me, and I'm like, man, I wish I knew how to do that. So I actually watched his live stream and was able to go through step by step and create the board. And you'll notice it has components, it has, the little copper holes and stuff like that. We did leave out the copper traces in this case, but I will probably show how you can create a PCB board. The other things I've added are the piece of glass, what's called a glass mask. It's just a thin piece of material, piece of plastic. You can kind of see it has a bumpy texture on it. That's what the lasers kind of shine through. And then this gasket, I know they're black, so it's kind of hard to see, but there's like a groove inside this gasket here. So we're gonna be assembling those. And then finally, there's this little drive shaft that's square on one end and rectangular on the other, and it's slightly tapered. So again, I didn't show how to model those. I just included them in this project. Okay, so what we want to do now is start assembling this thing together and making it realistic, like making things rotate that rotate, make things slide that slide, for example. And so that's what we're going to be doing. So the first thing I'm going to do is I'm going to pick a part that I kind of want to be my stationary part. And obviously the stake is kind of what's driven into the ground, and everything screws into it or rotates around it. So I'm going to call this my stationary part, but I want to move it. I'm going to move it to 0, 0. Now, I could create a joint, that's totally fine, or I could use the move command. And we're going to be doing lots of the assemble joint commands today, but I wanted to show this move command. You'll notice it allows me to move bodies. Well, I want to move components. I'll go ahead and hover over this component. You can see how it highlights, and you see my little triad kind of like flashing around and stuff. Well, in here, I have a point to point. And I'm going to zoom up a little bit, and let me go ahead and click on point to point. I'm sorry, my origin point is going to be, I'm going to hover over this edge, this top edge right here, and you'll see this little plus. So I'm going to go ahead and click on that little plus, and then my target point, you can kind of see it's drawing a line. And so basically what we're going to do there is, oops, make sure I'm doing this correctly. Target point. Oh, sorry. Need to select my component. Let me start over. Sorry, guys. So far, not so good. Let me go, component is that guy. Point to point. There we go. I'll make sure I'm getting that outer fillet edge, and I'll grab that point right there. And then my target point will be right there, and you'll see that it can move. I must have unselected the component, so even though I told it where to go, it didn't know what to move. Okay, so I now have moved that component to where it needs to be. Now you'll notice because I did that, I have this capture position, and I definitely want to make sure I capture the position. So when I do that, it's actually going to capture that in time, and it knows that this stake is where it needs to be. The next thing I need to do is I need to ground it, okay? Because even though I moved it, you'll notice I can still click and drag, right? I don't want it to move. So I'm going to, here's a little trick. If I just click on any part of my stake, it actually highlights it in my browser, and I can very quickly find it in my browser. You'll see kind of that underline dash right there. So if I click on any component, it'll actually highlight it in my browser. So that's a neat little trick. And you'll notice I've named everything. Please, please, please name your parts and components. It makes it so much easier. So I'm going to right click on stake, and the very first command is ground. And when I do that, it might be a little bit hard to see on the video, but there's a little thumbtack next to the component now. And if I try and click and drag on this component, you'll notice I'm clicking and dragging, it's not moving, whereas all these other parts I can move around no problem because they're not grounded. Okay. I'll go ahead and turn off the origin because I know that right there is my origin. The next thing I want to do is maybe start assembling this. So I'm going to use the joint command. And you'll notice in our latest release, we have updated what our joint commands menu look like. And I really like this. In fact, they've added an enhancement. I was always frustrated that between two faces was a right mouse click option instead of being in the menu. So they added that to the menu. So I'm really excited about that. Okay, same thing, component 1, component 2. You've heard me use this little phrase, which one do I move? Well, which component, which one do I want to move? This one. And where do I want to move it to? I want to move it to the stake. Okay, so that's how I know which one to click on first. So I'm going to zoom up. I'm going to grab this circular edge right there. So that's the one I want to move. Where do I want to move it to? I want to move it to this base. So I'm going to hover over this edge and click, and you'll see that it's going to move that component there. Okay, now it is two separate tabs. This is my position tab, and then I have my motion tab. And you'll notice by default, the last thing I did was a Revolute. So it wants to do a Revolute. And I could leave it a Revolute in this case because it kind of screws on, but it really doesn't matter too much in this case. So I'm going to say rigid because once it's screwed together, it's going to be rigid. However, I want the teeth of the gears to face a different direction. Okay, so I'm going to go back to this position, and I can grab this little rotate thing. And you'll notice I can actually rotate the position. So it's located in the correct location and on the correct axis, but now I can rotate it around 90 degrees. And that's what these options are right here. I could even offset it, for example, up a little bit. You know, let's say it didn't screw all the way in. you could offset it a certain distance. Let's just say 0.1 in this case. And you'll see it's still a rigid joint, but it's offset by 0.1. Okay, so that's what these little joint alignment options are. So I rotated it 90 degrees, and I'll say okay. Now, because that's a rigid joint, when I click and drag on this pivot, you'll notice that I can't pull it off of the stake because it's rigid. Okay, so the next thing I want to do is taking a look at this back housing. I want to apply this back housing onto this pivot point. So I'm going to do the exact same thing. I'll say joint. Okay, and then I'm going to zoom up, and I like to line things up. So I know that this hole has to line up with the other hole. So I'm going to pick on this edge. Now be really careful when you're selecting edges. And you'll notice when I'm hovering over this edge, you'll see my joint origin is right here in the middle. However, every single edge has a start point and an end point. And you'll notice that where I'm hovering right now, if I were to click, it's actually going to grab that particular point as my joint origin, and then things would not line up. So be aware as you're doing these joint commands that you're getting the result that you want. So you might have to, depending on where you're hovering over, you might get a weird result like that. So make sure you move off of it until you get the result that you want. So which is that guy there. I'll zoom out and rotate a little bit, and I'll zoom in and grab this point here. So again, watch what happens as I rotate around. You'll notice it's, in this case, there it is, right there. It's in a slightly different location in this case. So I want to make sure I'm grabbing that edge to get the center of that edge. Now I'm going to zoom out, and you'll see it kind of, I wish I was zoomed out. You could see it slide over and position where it needs to be. However, you'll notice it's kind of at a weird angle, okay? Now this does rotate because of the teeth. So I'm going to change my motion tab and click on Revolute, and you'll see that it gives me a preview that it's going to pivot around that axis. Okay. I'm going to jump back to my position tab, and I want to rotate this back so it's more vertical. So I'm going to grab this little rotate doodad and start to rotate, and you'll see, we can actually rotate around that pivot to make it look a little bit better. And let's go 97.8 degrees, some weird number. Now you're probably asking why. I'll show you why here in just a second. Okay, so I positioned it with a Revolute, and then I told it to be at a very particular angle. So I'm going to go ahead and say OK. And let me show you why that number. This is one of my favorite commands. Under the Inspect menu, Section Analysis. So I'm going to click on the Section Analysis, and I'm going to click on this front plane because I know it slices right through the origin. And now we're slicing through our design. Okay, we're sectioning through, and we can see what it looks like on the inside. So let me look at the front and zoom up a little bit. And notice the teeth right here. Okay, so if I were to edit this, this joint again, so let me go ahead and edit the joint, and I'm going to rotate, I can physically see that the teeth are no longer lined up. Okay, so this is how I came up with that 95.7 degrees. What was it? 97.8. I apologize. 97.8. So let me type that in. 97.8. And I can see that those teeth are in the indentations that they need to be. So that's how I came up with that number. Okay. Now, when you create a section analysis, I get this question a lot. It's like, okay, how do I get rid of it? Well, over here, you'll notice when I created it, it created an analysis folder. And if I expand that open, there's my section. I can have multiple section views, okay? or I can just click the little eyeball and turn it off. Click the little eyeball, turn it on. In fact, we're going to come back to this section analysis later on. So I'm going to turn it off for now. And there we go. You can kind of see that's where it needs to be. Okay. Let's work on maybe the center housing. I'm going to position this heatsink. So again, pretty repetitive. I'm going to be doing a lot of the joint command here. So let's go ahead and do, like, for example, that circular edge with this circular edge here. And you'll see it's going to move that heatsink up, and it's going to rotate it, and it's in the wrong location, etc., etc. So you'll notice that it's going the wrong way. Well, hit the little flip icon right here, okay? And it just basically flips the orientation. So instead of going in the negative X, it's going to come toward the positive X in this case, okay? But then it's also rotated the wrong way. So I'm just going to grab this rotate and rotate it 180 degrees, I'm sorry, 90 degrees in this case. And we can see that it's now positioned. I'll say okay. But check this out. I'm going to zoom up here and notice an issue. And unfortunately, I guess that part was kind of in the way. So it's a little hard to see, but let me zoom back up on there again. The holes do not line up. Okay, now why? Well, because I kind of freestyled this. I just took dimensions off of the parts with my digital calipers, and I tried to get as close as I could. A lot of the times it was guesses and stuff like that. But this is a real world example, especially when you're designing parts individually and then you're inserting them in and you're like, oh, these holes don't line up. So we're going to learn how we can fix this. This is pretty cool. Okay, so you might say, oh, just edit the sketch of this center housing, but you'll notice that all of these have little link icons, and that means that they're linked. And what that means is I can't come in here, for example, click on that face and, say press pull. You'll notice it's not going to let me click on any of these parts or any of these faces or anything to modify them because they're linked back to the original model, okay? And that's why you can't change them. So what we're going to do is take some measurements, and then we're going to edit the center housing individually, okay? So let me zoom back up on here again. I need to know how far off these are. So I'm going to kind of zoom up and rotate ever so slightly. And then I'm going to say measure, okay? Now here's another tip. I see this all the time when I'm helping customers. I'll say take a measurement. They'll click on inspect, and then they'll hit measure, right? Well, you can just click on this icon right here. You just click, and you're in the measure command. So I'm going to pick on this circle, which happens to be, this interior face. And I'm going to click on that circle. And it tells me, and it's kind of hard to see the dimension, but it's right there, that those are 0.028 apart. Okay? Now here's another new cool trick. Notice if I hover over any of these numbers, it says click to copy to the clipboard. Okay? So I'm just going to go ahead and click on that number, and it doesn't seem like it did anything, but it copied that into my clipboard, and that's important. Okay? Okay, so now I have the measurement. What I'm going to do now is right click on the center housing, because that's the model I want to change. And I can come in here and say open, about halfway down. And you'll notice I'm in my whole assembly. What it does is it opens up the center housing into its own session. And here is my timeline for that center housing. All of the information about it, okay? So basically what's wrong here is these two holes are too far apart. Now what I can do is I need to figure out where these are in my timeline. So I'm going to go ahead and click on one of these holes, and you can see that it highlighted a combine. Now this isn't all that helpful. The reason it highlighted the combined is because we made half of this, we mirrored it, and then we combined it together. But what this does allow me to do is it kind of helps me figure out where in my timeline was this created. So I know it was created before this combined. So for example, I'm just going to start moving to the left, and there's a sketch. I'm going to keep going, and there's a sketch, and you'll notice it actually kind of highlights that circle. So let me go ahead and edit that sketch, and sure enough, there is the sketch that was used to create that small hole. So that's a neat little trick. You know, click on it, and if it's not the exact feature, you can work your way backwards pretty easily and pretty quickly instead of trying to find in 60 features which one is it. Okay, so here is that hole. Now I need to move it in. So I'm going to double click on that dimension there, and then I'm going to paste. So now you'll see it says 0.04 space 0.028. And I obviously want to subtract. So I'm going to add a minus in there, and you'll notice it went from red to black, which means it's a valid dimension. And because I had copied that into my clipboard, it's using the exact measurement. It's not a rounded up number or an approximation. So when I hit enter, we're going to see that that 0.4 has now changed to 0.372. And it's moved over a little bit. Now here's the cool thing. We're way right here in the timeline. As soon as I say finish sketch, it's going to do all of the downstream processes. So I'm going to say finish sketch, and it did my mirror, it did everything. And I should have shown this before, but this little gap right here is now a little bit thinner. I don't know, this must be auto-saving. A little bit wider. So let me undo so you can kind of see that. So I'm going to undo back a couple steps, and you'll see it go from the larger hole to the smaller hole. Or the larger gap to the, the smaller gap to the larger gap. Okay, so I'm going to undo back, and notice how thin this little gap is right here. We make the change to the sketch, and apologize, it's taking long to push across. It shouldn't take this long. You'll see that little tiny gap become larger after we've moved that over. So there's a visual confirmation that sure enough, it made that change. Okay, so I've made the change. Notice I'm at version 1, and there's an asterisk next to it. That means that something has changed since we loaded version 1. Obviously, we've changed the location of the hole. So I'm going to hit save. Now, I could just say OK, but in this case, I want to be pretty descriptive. So I'm going to say, changed location of screw holes or something like that. Okay, that way when it goes to version 2 and I can view it, I can see, okay, what's the difference between version 1 and version 2? Oh, I changed the location of those screw holes. Okay, now watch this. This is really cool. I'm going to go back to my whole assembly, and notice there's a little warning symbol next to center housing. Let's go ahead and zoom back up on here. Notice the holes are in the wrong location. And it says the component is out of date. To update, use get latest in the model environment. Okay? I could either click on this icon, or I could right click and say get latest. And watch what happens to these holes when I say get latest. It's actually going to go out and grab version 2 of the center housing, and now we can see that sure enough those holes are lined up. Okay, so this is really cool, I think. We're designing individual parts. We're hoping that they all line up. I usually project geometry and stuff like that, but I was trying to, in this example, show coming from other CAD systems, maybe SolidWorks or Pro-E or Inventor or whatever, what things you might run into. And this is one of those where things don't line up, but it's so easy to make a change. and go back to the original model. And that's what's so cool, is that these are dynamically linked to the original models, and if I make a change to that model, this assembly will update. Okay, so let's move on. Now that we've put the heatsink in the correct location, I want to assemble it in there. And again, I could turn off other parts if I wanted to. So for example, I could turn off this back housing so it's not in the way. Maybe the front housing, I could turn that guy off also. Okay, I want to create a screw right here. So I'm going to use McMaster Car. Hopefully you all know that the McMaster Car library is built right into Fusion. So let me expand this open a little bit. And I'm going to go into screws and bolts. And I want to have one of these guys, like tapping, wood, drywall screws. I'm going to click on that guy. And then I want tapping screws for plastic in this example. I'm going to click on that guy. Okay. Then you'll notice they have a whole bunch of different kinds. I'm going to just use the basic 18/8. And I want to do a number 0 by 3/4. I'm sorry, by 3/8. I lied. So a number 0 by 3/8. So I'm going to go ahead and click on that number there. And if it has a little CAD symbol, I can click on this product detail, scroll down, and it shows an image of it. And then you have different options on how you want to download this. I want to download it as a step file, so I'm going to hit save. Now what this does is it brings it in, and of course it brought it in at 0, 0, 0. So it's hidden inside of my stake right there. So I'm going to pull it out, and let's just move it something like this. Now I usually try and get it sort of close. I mean, that's just personal preference. I could even rotate it to have it going in the correct direction, like so. You don't have to, I like to. Now, here's the catch. When you insert a McMaster Car component, notice you don't get that free move. So if I don't capture the position, in fact, I'll go ahead and do this. I'll show you what would happen. I'm not going to capture the position. I'm going to say okay, and yay, there it is. But as soon as I go to do something, it's going to say some components have moved. Do you want to capture the current position, or do you want to continue? If I say continue, it's going to put it back inside the stake right here at 0, 0, 0. So in some cases, you're going to want to capture the position and then do your move, your joint. So I'm going to rotate around a little bit, zoom up, and I'm going to just hover over this circular edge right here. So it's going to grab the center of that edge, and then I'll do the same thing over here. I'm going to hover over that edge and click, and you'll see it slide into position. It remembers our last motion type was a Revolute. So if you wanted to, you could leave it a Revolute. Or in this case, I'm going to just say it's a rigid joint. Okay, it's really up to you what you want to do there. So I'll go ahead and say okay. And we now have a screw right there. So I'm going to do the exact same thing without as much talk. So I'll say inspect. Actually, no, I lied. I'm going to copy because I want to show the copy functionality. So I'm going to click on that screw, right mouse click, and say copy. Okay. Now I want to put another screw in this assembly. So I'm going to right mouse click at my top level and say paste. Okay. Now you'll notice I have paste and I have paste new. Paste new is if you want to create a copy of something, but you can change the original and it won't change the copy or the clone of it. Okay. If I say paste and I changed one of them, the other one would change also. So I'm going to just say paste because I want them to be the same. Now I want to position these. Okay. I'm going to just drag it over here kind of where it's in the open air. I'll say okay. and then I'm going to create a joint. Now, why would I use a joint versus using maybe like a move command, like a point-to-point move command? Well, the reason for this is because I want the smartness of the assembly to happen. So if I were to move this guy here, you'll notice that those screws and the heatsink all move together because they have rigid joints with this particular part here, the center housing. Okay, if I had just copied and pasted and moved this screw over 96 millimeters, whatever it's supposed to move, and then I came in and moved this guy, that screw would have stayed in the exact location where it was, and it wouldn't have moved. So that's why we're creating the joint command. Okay. The next thing I want to do is hook the stepper motor. We have this little tin can stepper motor that needs to go into place right here. And I'm going to purposely make a mistake, and then I'll show you how to resolve that. Okay. So I'm going to use the joint command, and I'm going to select that edge there, and I'm going to select this circle edge over here, and you'll see that the piece of metal moves. Again, it's in the wrong location, so I'm going to flip. So now it's correct, and then I'll rotate it 90 degrees real quick. In this case, 270. Depends on which circle you pick. Now watch what happens when I say OK. It just moved the top cover of my stepper motor. But you'll notice that the stepper motor is all like this component with a whole bunch of individual subcomponents underneath it. Okay, but I told it to move just that particular part. So how do we fix this? Well, the easiest way is to come in here, and because this is all one thing, I'm going to come under the Assemble menu and say Rigid Group. What are the components? I'm just going to click on that top level tin can stepper motor, and you'll see Include Child Components. So it's going to include everything underneath it, all the children underneath it. I'll say OK. And now if I do that exact same joint, so I'll make sure I grab that circular edge and that circular edge. Now here's the thing that's going to freak you out. It looks like it's doing the exact same thing. Well, remember, we're only dealing with two components at a time. Component 1 is the one we want to move. Component 2 is where we want to move it to. I want to flip that around. I want to rotate that. But watch what happens when I say, I'll zoom out. Watch what happens when I say OK. The rigid group has to move to where the other part is. They have to stay grouped together. So sometimes, you know, when you go to move a component, it looks like it's not moving the rest. Go ahead and hit OK and see if the rest move. If they don't, you can always go back and make it into a rigid group. Okay, so I now have the stepper motor where it needs to be. And I didn't include every single little tiny screw in here. If you want to, please feel free to go to McMaster-Carr and create, maybe measure what the diameter of this hole is and find a screw that would fit inside that hole and add those in. I'm just doing kind of more of the major ones and showing you how to do some tips and tricks with those. Okay, so we got the stepper motor where it needs to be. Now what I want to do is position this circuit board. Okay, so same thing. I'll save us some time because I'm going to go long again. This is a whole bunch of subcomponents. So you can see I've got my 3D packages. I've got the solder mask. I've got the copper traces and stuff like that, copper pads, etc. I want to group all of this together before I move it, okay? And that is the starboard, okay? So I'm going to come in here and say rigid group, starboard, not aft, but starboard. Huh? I'll say okay, cheap humor, I'm here all day. Okay, now if I do the joint, I'll again pick a top edge like that, and a top edge like this. Now, again, it looks kind of weird because it's only moving one thing. In this case, it almost looks like it's moving the mask. So I'm gonna flip that around and rotate that down the 90 degrees. But as soon as I say okay, you'll see the whole board, because it's a rigid group, it all moved together. Pretty cool. Okay, now I want to assemble this. I'm going to use a screw for this. So again, I'll come in here and say insert McMaster car. I'll move this up a little bit, make it a little, I like to make the window a little bit bigger so you guys can see. Screws and bolts. Now I'm going to do something a little bit different this time. So I know I want to pick a screw or bolt, but I'm going to use the filters over here on the left. So I want to pick a particular size. So I'm going to come in here and say I want a 356 in this case. And you'll notice that it starts to filter things out. I also want to make sure that it's a Phillips drive style. So I'll click on Phillips, and now it's only showing certain screws in that size that have Phillips heads. So it's kind of a cool way to filter things out. So I want to do 1/4 inch long, which is this guy right here. Product detail. I'll say save. Again, it brought it in at 0, 0. So I'm just going to quickly, I can even use these planes to kind of, do X and Y, or I'm sorry, X and Z in this case. And this time I'm not going to rotate it, just to show you don't have to. So I'm going to go ahead and let me bring it over to this side. Sorry. I'll go ahead and say okay. I'll capture the position so it doesn't jump back to the center. And I will do a joint right here, that edge. And let's just start maybe at the top left. And I'll click on that edge. And you're going to see it's going to move the screw, but it brought it in the, again, flipped direction. So I'm just going to hit flip. You can see how you can rotate the direction. And you'll notice that, the edge that I clicked on is the edge that it's sitting on that board. We can see that it's actually going into the screw hole. It's the correct size and everything like that. It's pretty cool. I'll go ahead and say okay. And I now have a screw. Now I could do that 3 more times, but that would take some time. I'd have to go into my MasterCard, click a bunch of times, whatever. Well, this is a rectangular pattern. So let's go ahead and say pattern, rectangular pattern. I want to make sure I'm patterning a component. So I'll go ahead and say that screw there. Okay. Then I can specify the directions. So I'm going to say that direction. And this is what Jason was showing last week on his live stream. I'm sorry, earlier this week on his live stream. Selecting both directions. So I can now start to drag this direction, and you'll see the preview. Let me move this guy out of the way. You can see that there's 3 screws. I'm also going to start to drag this direction, and we can see that there's 3 going that way. Well, I want only 2 going this way. Okay, and I'm concerned about the spacing, and I know from my drawing that the whole spacing was 2.8. So I'm going to type in 2.8, and you'll see that it jumps over there. Okay. Or I could have measured the distance between the 2 holes if I didn't have my drawing. I also know I want 2 screws going down this direction, and that distance was, according to the drawing, 0.95. I'll say okay. And now I have 4 screws. Now, this is what I was talking about earlier. Watch what happens if I move that component. See how those 3 screws don't move with it? That's just because they were basically moved. They weren't, they weren't created with joints or anything like that. So I could do joints for all of those, but I'm going to say rigid group. I know that all 4 of these need to stay in the same location. And because this one was created with a rigid joint, the rest of them will move with it. So if I were to move it now, we can see that they all move. Okay, now, again, this is personal preference. I get asked every so often, does it matter if I create 4 joints all the way around? You can absolutely do that. Or could I do one and do a rigid joint? Again, it's totally up to you, or even a Revolute joint. It's up to you. I kind of think it's faster to group them together and have less joints. Okay? Okay. So what I'm going to do now is I want to start positioning the gears, and I want to simulate how these gears are going to move. Well, I don't want the center housing to move, so I'm going to ground the center housing temporarily. So I'm going to say ground, and you'll notice that it's pinned. You can actually ground multiple objects. It doesn't have to be just one. So keep that in mind when you're designing things. If it might make sense to ground a couple different things to simplify instead of having to create rigid groups or extra joints or whatever. So what we're going to do now is we're going to position these gears, and one of these gears is a drive gear. You can kind of see that here. And the other one is the lens gear. Okay, so I'm going to position the drive gear first. So let's go joint. I'll click that edge there. I'll click on like that edge there. You'll see it move into position, and for whatever reason everything is flipped. So I'm going to hit flip real quick. Okay, so I want it to look like that. You can see that it's sitting right on that plastic boss, but it's not moving. So I'm going to go to motion, and sure enough, it's a rigid joint. I'm going to say Revolute, and now I get a preview of what that's going to look like as it's revolving around that axis. And that looks good. I'll say OK. And if I were to grab on that gear, you can see that we can rotate it. Now, if I hadn't grounded my center housing, it would have just moved with the center housing. It wouldn't have let me rotate it. So that's why we ground it. If I unground it and I try to rotate this gear, see, it won't let me rotate it. So that's why we did that temporary grounding of the center housing. Okay, same thing. Let's do a Revolute joint from there to maybe this edge right here. Again, making sure I'm not grabbing an end point or whatever. Sometimes it's hard to find that end point. Right there it is. So I want to make sure I'm grabbing that edge. It's going to position that gear. I'll flip it around. Now, I'm not going to spend a lot of time on talking about gear ratios and all that kind of stuff. And you'll notice that the teeth don't really engage all that well. Again, this is my fault. It's because I just, took some basic measurements, and I'm guessing that this gear is slightly smaller than it needs to be, but it'll still show you what needs to happen. And in a future session, I'm going to talk about fixing things like this. Like maybe we could actually move the center of this gear up a little bit to make it engage better. But that means we're going to have to change the center housing. So again, that's down the road. But what you noticed is when it first positioned it, those teeth were kind of like overlapping. Okay, so I'm just going to rotate them so they're not overlapping, something like this, maybe around 96 degrees or something. Okay, I could also type in a number. I could just say, like, for example, minus 96, and it'll snap to that particular number. Okay. Now, if I rotate this gear, you'll notice nothing really happens with this other gear. Not very realistic. Okay. I could come in here and do what's called contact sets, but in this case, I'm not going to. We're going to do something called a motion link. Okay. Now, what this allows you to do is to link two joints together. So I'm going to start with this one down here. Okay, and we can see that's called Revolute 12. Then I'm going to click on this one here, and that's called Revolute 13. Now, I'm going to hit animate, but it's kind of hard to show. So when I hit animate, it's going to preview, but it's jumping too fast and stuff like that. So I'm going to just say okay. So all I did was say link those two together. Now watch what happens when I drag this gear. We see a couple problems. First of all, the other gear is rotating the wrong direction. Okay? So let's go ahead and expand open the joints. Here's that motion link. The very last thing in the list, I'm going to edit that feature, and you'll notice there's an option in here called reverse. I'll say okay. Now when I drag to the right, the gear is rotating the correct direction. But watch what happens when I start going farther and farther and farther. You'll notice that the teeth are starting to clash with each other. Now why is that? Well, it's because this gear is actually larger than this other gear. It's a different gear ratio. Okay? So what we can do is we can come in here and say, for every 360 degrees that the big gear rotates, I want the smaller gear to rotate 376 degrees. And I'll tell you how I came up with this number here in just a second. So let's go ahead and rotate now. And I can keep rotating, keep rotating, keep rotating. You'll notice that the teeth aren't clashing anymore. And that's because we've specified that ratio of, for every 360, this should be going 376. Okay. Now, how did I come up with that number? I just rotated around and around and around until I saw when it was starting to clash and I backed off a little bit. Okay. Again, not a glamorous way of figuring that out. I probably could have figured it out with gear ratio math and stuff like that, but I'm not good at math. So I just did it visually. So again, I said I'm not going to go in too much into depth about like gear ratios and stuff like that. I could actually turn on the sketches for these, and they actually have the axes of the teeth. I could make those tangent with each other, but because this, let me jump back to here, but because these are lined up perfectly with these circles, I'm not going to worry about that. Okay, so let's do the exact same thing. I'm going to create a copy. Let me turn off those joints. I'm going to create a copy of my lens gear. So I'm going to right click and say copy. Right click my top level, say paste. It's going to position it out here in space somewhere, and I'll just leave it right there for now. I'll go ahead and say okay. And let's create a Revolute joint from there to there. Flip the alignment, say okay. Now, if I were to rotate this gear, you'll notice that other one doesn't rotate because we haven't created that motion link. So let's go ahead and do that. So I'll come in here and create another motion link. That guy and that guy. And I know 376, so I'm going to type that in. Let's try to rotate, and sure enough, I didn't have to reverse that one. It actually rotates in the correct direction. So now you can see that this stepper motor is going to turn this gear, and it's going to revolve these little, there's little eyepieces in here that make the lasers kind of sparkle and stuff like that. That's how this thing works. Okay. So let's actually connect the stepper motor to this drive gear, and that is this little drive shaft right here. So I'm going to create another joint. Let's zoom up, and I want to catch to the center of that rectangle. And you'll notice if I hover over this face, it actually lets me catch to the corners of the rectangle and the center of this axis here. So I'm going to click on that because this is the one I want to move. Where do I want to move it to? I want to move it to this little gear in here, and it's going to be kind of hard to see. But I'm going to jump in here, and let's turn off the center housing temporarily. And I'm going to do the same thing here. I want to catch to the center of this surface. So you'll notice when I hover over it, it's doing the rectangle, but then there's that little center mark. So when I click on that, it's going to line up that drive shaft. And I don't know if you saw the animation of that part rotating, but it's lined up and it's rotating there. Okay. However, I want to back it off ever so slightly in this direction. So I'm going to drag it so you can kind of see what's going to happen. If I pull it this way, it's going to come off of that post. But the reason I want to back it off a little bit is because, I want to make sure that it's engaged with the shaft here. So let's just back it off maybe, I think in the directions, I just say like 0.05 in this case. You can kind of see it move. I'll say okay. And if I were to rotate the gear, you'll notice right in here what's happening when I rotate the gear. So you can see that sure enough, that drive shaft is rotating also. So now we have a mechanical link between the stepper motor, the drive shaft, the gears, and those are rotating around the center housing here for the lasers to shine through. So hopefully that kind of makes sense how and we're kind of assembling this as like a sub-assembly, which is kind of, we did this out here in space. Now that we're happy with it, I'm going to unground it. Okay. Make sure I'm on track here. So what we want to do now is position it with some of these other parts. So I'm going to turn the back housing and the front housing back on, and I'm going to create a joint, and I want to position this subassembly onto this back part, and you'll notice it's at an angle. So what I'm going to do is it kind of slips into place. So I'm going to hover over this edge right here, and you'll notice my joint origin, and then when I get to that end point, it kind of lays out flat. And I do not want that. I actually want to catch my joint origin to the end of this line. So I'm going to hover over this line, and I want to control my selection. So I'm going to hold down my control key on a PC, and you'll notice it kind of snaps to that end location right there. So I'm going to click, and my joint origin, it's kind of hard to see, is right at the top edge right there. And then I'm going to do the same thing over here. I'm going to hover over this edge, hold down my control key, and you'll notice that it's kind of grabbing the exact same point. So when I click there, you'll see something interesting happen. Okay, it lined those points up, but because my last motion type was Revolute, it wants to revolve around, which obviously we don't want. So I'm going to change that to be rigid. Okay, but notice all my parts are out here in space. As soon as I say okay, boom, it moves all of those parts where they need to be. And I can rotate this guy forward and back. I can rotate the gears, all that kind of stuff, and everything moves with it. Okay. Let me revert that back. One of the tips that I do is I try and build my joints kind of in order, like how this thing is going to get assembled. So instead of doing a joint over here, and then one over here, and then one down here, I kind of build my joints kind of on top of each other. And to me, it makes more sense instead of being so random. So hopefully that makes sense and will help you. Okay, let's continue on here. We're at the top of the hour, but we're pretty close to being done here. We only got a couple more parts, so I want to assemble let's do the glass stuff next. So I'm going to almost do it like a sub-assembly like we did before. I want to position this mask, and again, I want the front edge. So I'm going to go ahead and click on that front edge, and then I'm going to click on the back edge of the glass. And you'll see it's just going to rigidly stick that on there, basically. Okay. Then I might come in here and say I want to create a joint from the front edge of the glass to the inside front edge of this gasket. So it's kind of hard to see, but there's that inside front edge. I'm going to go like so. When I say okay, that mask should move into place, and now we basically have this sub-assembly of this rubber gasket, the mask, and the glass. Okay, then I can come in and say let's join the front edge of the gasket to the front edge of this interior face right here. So I'm just going to click there, and you'll see the gasket jump into place. Let me zoom out. You can see all the glasses over there, but as soon as I say okay, everything moves together, and we now have the front of our housing with the glass and the mask and everything like that. Then I want to position this guy in. Now it's kind of hard to see, but there's these little standoffs inside, and on this, what part is it? It's called the mount. There's these counterboard holes right here, and they go all the way around, and those actually slip onto those posts. So I'm going to go ahead and say joint. I'll zoom up. Here's another tip. Please don't try picking edges like this far away and stuff like that. It's really kind of hard. I recommend taking the time to zoom up, and that way I can make sure I'm clicking on the correct edge. It could either be this one here or this one here. It really doesn't matter. They're both on the same plane. So I'm going to grab that top one there. You can kind of see the top has that little notch. So I want to make sure I grab the top one there, and we'll see that that kind of slide into place. And I'll say okay. And there we go. And then finally, let's join those together. So I'm going to create a joint. Just like we did before, I'm going to hover over this top edge, making sure I grab that point there. And this slides on top of this part, so I want to make sure I'm grabbing the correct edge. This is not the correct edge. I want to grab this edge right here. I'll click on that point. We'll see the front housing kind of jump into place, but as soon as I say okay, everything assembles together. We still have this guy, which I'll fix here in a second. You'll notice it moves with it, so it must be a child of an assembly. But you can see how all those parts move together. Okay, so let's take a look at this guy here. So I'm going to click on it, and it says back housing. Okay, so I'm going to expand open back housing, and sure enough, this was actually saved with the back housing. It wasn't saved individually. So that's why you can see it's underneath here. So I'm going to do the exact same thing. I'm going to say rigid group. I'll click on that guy right there, make them all move together, and I'll do a joint. And I want to catch to the front. This is a little rubber gasket right here, so I'm going to catch to that little rubber gasket and zoom out a little bit. And let's take a look right there. And you'll see that the gasket's going to move into place. And as soon as I say okay, all the rest of that will move into place. And it all moves together. Okay, almost done here. There is a knob that needs to go through here, and like I've said many times, I love McMaster Carr, so I'm going to do this, and to save time, you can actually search for knobs or whatever, but you can also, if you know the particular number, like if you went to McMaster Carr's webpage and searched for it, you can actually come in here and say, you know, the actual product number. So I'm going to search for this 245, etc., etc., and you'll notice it's a 4-armed polypropylene plastic knob, okay? And yeah, comfort grip knob, 1032 threaded stud. So I'll click on that. We can see what that's going to look like. And I'll hit save. And how much time did I just save instead of having to model this or whatever? I'll go ahead and rotate it like so. Let's just move it a little bit out of the way. I'll capture the position. We'll create a Revolute joint. So here's another tip. I hit joint. I can go to motion and actually tell it it's going to be a Revolute joint. Okay. And then when I come in here and click on this guy here, this is the one I want to move. And I want to move it to here. you'll see it's going to go over, and then in the preview it will, oh sorry, I was rotating, you can see it rotate. So I told it I wanted it to be a Revolute joint, and so it actually created it as a Revolute joint. Instead of remembering my last one, I kind of forced it to be a Revolute joint. We can kind of see the threads coming through right there. And then lastly, there needs to be a nut. So I'll do, again, a McMaster-Carr component. Or I could use the manufacturer parts. I showed this in one of my other live streams. There's lots of parts out here from different manufacturers, so you could do that also. Okay, so here I'm just gonna click on nut. I want to do a hex nut. So let's do, and I just need to remember what size, hex nut. Let me make this a little bit bigger. Okay, now here's the thing. I'm gonna filter down. I want to pick a particular size. So I'm gonna say 1032. Okay, and you'll see it shows which ones are 1032. But then if I scroll down, I want to do a narrow profile, okay? Because it's fitting into a smaller hole. And I'm just going to go ahead and pick this 1032 right there. Product detail. Allows me to download it. I'll bring it out so you can kind of see what that looks like. Capture the position. I told you a lot of repetitiveness here with, you know, creating joints and stuff, but I wanted to show how we assemble all of these components together. And then I'm going to show you something pretty interesting here in just a second. So I'm going to zoom up, and you can see that it's actually recessed in this little plastic part right here. And I'm just going to grab that circular edge, and it's going to bring the nut in there, and it's going to rotate around. But you'll notice it's kind of off a little bit. Well, I can just grab that and rotate it until I get it to something that looks good. Let me just say like 7 degrees in this case. I'll say okay, and we now have that whole assembly. Now you'll notice this part is gray, so we'll say appearance. Here's all of our appearances. I think in one of my earlier live streams I talked about, you know, creating favorites, and we created this blue plastic as a favorite. So I'm just going to drag and drop that on there, and sure enough, there we go. Okay, so we are going a little bit over again. I apologize. You'll notice as I'm rotating around, you'll see all of these joint icons kind of flashing around and stuff. And I'm pretty much done creating all the joints, so I want to turn those off. And there's actually a couple different ways you can do this. If I go to my display settings down here at the bottom, object visibility, I can turn off joints, and you'll see that they turn off right there. Okay. I can turn them back on again just using that toggle. Or I can just hit the eyeball next to the joints folder right here. So if I hit the eyeball right there, it turns them off. Pretty much, you know, similar thing. Okay. Okay. Remember earlier I was talking about that section view? We're going to come back to it. So check this out. I'm going to turn on my analysis, and here we are looking inside the parts. Okay. Now I want to just talk about the section view here a little bit. So I'm going to right click on section and say edit. Now what this allows us to do is I could change where it's located and stuff, but one of the things I wanted to talk about were these last two options right here. So you'll notice one says show hatching. If I turn that off, it turns off the hatching, and some people think this might be a little bit easier to see, so I can turn those on or off. But then this section color, it says from components. So you'll notice we've got some green, some orange, some blue, some pink, etc. I could say custom, and I can pick a custom color. So for example, if I click on this, I could say I want this to be, you know, some kind of a cyan hatch or whatever. Okay. I kind of like to do the bright yellow personally, and I'm going to turn off hatching. Let me say okay. Turn off hatching, and we can kind of see what that looks like, and it's really kind of bright and vibrant. Okay. Now if I zoom up, you'll notice an issue right here. Okay, our circuit board is clashing with the back housing. So what do? Okay, we've designed all of these parts. we've assembled all together and now there's something wrong. And this is where I think the real magic of Fusion is. So we're gonna go back and make a change like I showed earlier and watch the update happen. So actually let me edit that. I'm gonna change that back to the custom. I'll say okay. I'm gonna leave this hatching the way it is. Okay, now I know that that circuit board is attached to these little studs right here, and those studs are a certain length. If I were to shorten those studs, the circuit board should update with that. So that is, let me click on that. That's the center housing. So let's go ahead and open that up again. So I'll say open, and it brings up my center housing. Okay. I'll click on that stud, and again, it didn't highlight the actual extrude, it highlighted a combine, but I now know where in my timeline I could kind of start working backwards. And so here's an extrude, those are for the fins. Okay, there's an extrude, there's the extrude for the studs. So kind of a cool little trick. Like I said, just click on something, it'll highlight, in the timeline. And if it's not the exact feature, like if it was a fillet feature, let me see if it'll do this. If I click on that fillet, it'll highlight that fillet feature, right? Because that one wasn't mirrored or anything like that. But because this was mirrored, it shows the combine. And then I just went back here and let's edit that feature. Okay, so you can see some of the stuff's disappeared because we've gone all the way back in time to this extrude. And let's just go back. Oh, I lied. Let me go back here real quick. I skipped a step. How far should we move this? So let me show that. I apologize. I'm gonna hit measure, and I'm gonna pick 2 points. So you'll notice as I'm moving around, it's trying to catch to edges and surfaces and stuff like that. So I'm gonna get fairly close and click right there. Now this has a chamfered corner, so I'm gonna click fairly close and grab this other point. And you'll notice it says 0.237. Now be aware of this. I'm gonna rotate and you'll notice the measurement. Because I clicked 2 points, those 2 points could be anywhere in space. So be aware of that. I use this XYZ delta all the time. Let me zoom up so you can kind of see what's going to happen here. I'm going to click on XYZ delta and you'll see a bunch of numbers appear. So what it's doing is it's actually giving me the distance between those 2 points in 3D, but then it's also telling me in 2D, in the X direction, which you can see going left to right here, is 0.055. Okay, in the Z direction, which is up and down, the difference between those 2 points is really small, 0.003, right? So this is the important number right here, 0.05, okay? So I like that XYZ delta. Okay, now I can come back in here, I'll edit that extrude. Now I only have to go 0.05, but I want to make sure I have enough room, so I'm going to do basically 0.1. So I'm going to go from 1.6 to 1.5. So you can kind of see how that's going to update my 3D model just ever so slightly. That's 1.6. There's 1.5. I should be okay with that. I'll say okay. All my downstream features update. There's a little asterisk, which means something has changed. So I'm going to go ahead and save that. And I'm going to say changed length of studs to 1.5. Okay. I'll come back to my whole assembly. Let me zoom back out a little bit here so you can kind of see what's going on. We notice that little warning symbol. I'll say, and I get the warning over here, one component is out of date. So I'll just right click and say get latest, or I can click on that icon up there at the top. Okay, watch what happens when I say get latest. Takes a second to update, but boom, the whole circuit board, the screws, everything moved because that stud length changed, and we've created all of these with joints and all that kind of stuff. It all moved together. Okay. Now, the last thing I want to show, I'm going to turn off my section view. I use the inspect interference a lot also. So I told you section analysis I use all the time. I love it. This is probably my next favorite one. So I'm going to say interference. And it's allowing me to select. Now I could draw a box around the whole thing, but I'm going to just select maybe the housings, the front, the middle, and the rear housing. You can see it says include coincident faces. That's going to tell me if the faces are touching, which is okay, but what I'm more concerned about is are the faces clashing. So I'm going to leave that alone, and I'm going to click on compute. And it kind of ghosts the objects a little bit, and you'll see that it did find a clash between the back housing and the center housing. And if I rotate around, you can actually see it highlights it in red. So those little fins that are connected to those little studs are actually clashing with this back housing. So I was able to find another issue that I need to correct before we were to assemble this whole thing together. Okay, because we've gone 20 minutes over, I'm not going to fix that, but I wanted to highlight that. Please feel free to fix that yourself if you've been following along and you have these models. If it were me, I'd probably just chamfer that edge so it kind of squared it off a little bit. What I'm going to cover next time is the wiring. I might talk about how I created that circuit board, and maybe we'll do some wiring on the inside. But this is pretty much it. I mean, in about 6 sessions now, we've actually created this whole assembly with decals, multiple different components. We've added the joints so the thing rotates and stuff like that. So hopefully you're finding this useful. Look forward to seeing you on a future live stream. Again, make sure you go out to our Fusion 360 Live YouTube channel. We're constantly adding new live streams out there. Check the times and dates and sign up for them. So I know there's a cam one tomorrow. There's another one on Monday. Jason's team, they're doing a bunch of stuff on Tuesday. And then all of the PCB stuff on Wednesday. We're doing a whole bunch of them. So again, thank you for your time and hope to see you on a future live stream.